Hello guys, I would like us to look at how to evaluate the following double integral. Now, given such an integral, what you do is when you come to evaluate it, you will start by integrating what is inside. So this is the first thing we'll do, integrate this with respect to x. And then whatever answer we get, we'll now integrate it with respect to y. Now, integrating this with respect to x, we don't have x here. So the whole of this is going to act as a constant. So we'll treat it as a constant. So assuming this is a constant like 5, if we were to integrate 5 with respect to x, then we'd get 5x. So similarly, integrating what is inside, so let me have this. And then integrating exponential y squared. Exponential y squared is a constant, then we'll just have x besides it here. Integral from 0 to y. So we've already integrated what is inside, and then we have our dy besides it here. Now, we're going to replace the values of the range. And where are we going to replace? We're going to replace them where there's x, because what we integrated was with respect to x. So we'll have integral from 0 to 1 exponential y squared, where there's x, I'll replace with y, minus exponential y squared, where there's x, you put 0. So all this and then your dy. Now, this is going to give us integral from 0 to 1. Let me write y exponential y squared, and then the whole of this will give 0 dy. Now, we want to evaluate this integral here, y exponential y squared dy. As you can see, we have an algebraic function here, and we have an exponential function here. Now, looking at the power here, this is y squared. If we differentiate y squared, we get 2y, which is close to this. The only thing missing is the 2. So we can use algebraic substitution to integrate this value here, where we say let u be equal to y squared, such that du dy is equal to 2y. So we can be able to rewrite the whole of this. We can be able to rewrite the whole of this so that we have integral from 0 to 1 of y exponential u. Now, what is our dy here? Come here, you have du dy is 2y. So making dy the subject of the formula, we'll have du over 2y is equal to dy. So we come and replace dy, we'll have it as du over 2y. So evaluating this y will cancel with this so that we have integral from 0 to 1 of a half eu du. So you see the substitution has simplified this so that now it's integratable. Now, what is the integral? I can write a half outside. What is the integral of exponential u? It is exponential u. And we have our range from 0 to 1. However, this range from 0 to 1 was a range that was supposed to be replaced on the y and not the u. So we'll rewrite our equation back to y. So we'll have a half exponential, instead of u, we had replaced it with y squared. So where there's u, we put y squared. And we are integrating from 0 to 1. So this is going to give us a half exponential, where there's y, we replace with 1 and then 0. So we're going to have a half exponential 1 squared minus a half exponential 0 squared. Okay, and this simply gives a half exponential, 1 squared is 1, so a half exponential, which we can now evaluate in the calculator.